We are very lucky to have Sean join us all the way from Australia. Thank you, Sean, for staying up late at night to present to us. Sean's been in the industry for over 38 years and amongst other things, and a very wide background, he now looks at supporting mobile and fixed operators, IoT service providers, utilities and enterprises, and how to facilitate the adoption and deployment of IoT solutions. He's going to be presenting today on the future of provider services, leveraging IoT and cloud technology for the connected home, business and enterprise. Sean, enough from me. Let's hear from the experts. Over to you.
Thank you very much, Craig and team. Welcome to everyone, and from everyone around the world. So without further ado, let's jump into this particular presentation around the future of provider services, leveraging IoT and cloud technology for the connected home and for business and enterprise. So just a little word on Friendly Technologies, who we are. So Friendly Technologies, we've been in business for over 30 years. And our bread and butter business is device management. That's our core focus. We're a software development company developing software products. And on the screen, we have a few products. One of those is our One IoT Unified Device Management Platform. Built on top of that, we have a smart home automation platform. We have our traditional TR069 device management platform serving sort of more the broadband market. Of course, we have some Wi-Fi management tools, some quality experience monitoring tools, and then we have a suite of embedded clients that we sell as software development kits and provide professional services to clients wanting to add their devices into this ecosystem and wanting to use standards-based device management from device to network or cloud. Okay, so with this background, I mean, we're obviously aware of the downward pressures in revenues from the service providers, really all competing in the market with their voice, video, data services, and looking for new opportunities to create new revenue streams. So this is a very sort of complex market globally, and operators are generally trying to look for these sorts of additional revenue streams. So without further ado, obviously the most obvious solution here is to stand out with new services. So looking at reaching new clients, increasing your ARPU, increasing that loyalty and decreasing churn, and as well as monetizing that new data that is derived out of these new services. So what you will find is the CSPs are running dozens of pilots annually, and there are many different devices and services being piloted. So the race is on. So a part of the challenge in this sort of devising new services and new products for the market is a few-fold. One of those is obviously having to add new devices and new services to your product that you want to launch. So when you start looking at new products, there's obviously a lot of challenges around that. You need to test and experiment with these devices before you make a decision on this new service. There's new types of devices that may require, different sort of level of support and exposure, additional protocols. You can see sort of in the second stage launch here, there's multiple protocols for different sorts of IoT devices or broadband devices. And this starts getting quite complex when you're trying to sandbox and piloting sort of these new devices and new services. So each of these steps costs additional time, costs additional investment, and this is not to be sneezed at. It is a significant undertaking. So part of the solution here is looking at using a unified device management platform. So this is sort of a device management platform that forms the central device registry within a service provider. A central device registry is a fairly important part of this equation, because if you look at multiple services being offered by a service provider, such as it could be, just broadband devices, it could be, smart home, it could be telematics, it could be utilities services, whatever the particular service is. And generally, you find that there are different platforms and different management systems for all of these different types of solutions. And this creates a huge challenge for a service provider in terms of managing that the ecosystem on each of those platforms, managing the support, and just managing, sort of gluing everything together. So we talk about this unified device management platform being the central device registry, providing future-ready capability, providing protocol agnostic capability, as well as being a completely automated solution, so that you're able to bring on aboard devices very easily and simply. So with the platform like this, to be able to quickly and affordably test and pilot new services. And of course, you want to be one step ahead of the competition by tailoring those new services and evolving the market demands for your particular solution that you have to offer. So there's a plethora of devices that generally go into offering a solution to the markets, would be that an IoT vertical solution, or be that a smart home solution. So we're talking here about everything from an embedded module. This could be a small IoT-based type embedded module, all the way through to sort of higher end gateway applications. And in each of these sorts of areas, there are different complexities with devices and the communications, and so, of course, the management and control of these. So we talk about resource constraint devices. So these very low power, ultra low power sorts of devices that could be wearables, that could be smart meters, that could be parking sensors, whatever the particular target device is. It would be quite a challenge to onboard and manage those sorts of devices. We also look at sort of whole myriad of sensors, and they all have various protocols and sometimes often different access networks as well. So whether that's sort of RF networks or cellular networks or whatever the case may be. And then moving up into modems and routers, getting a little bit more feature rich, getting a little bit more functionality, potentially higher throughput, more capacity, such as going on to 5G. And then from a gateway point of view, looking at things like smart home applications as an example, where you're able to run edge applications, whether that's a smart home edge application in the device, it could be a container or microservice. And, so that opens itself to a whole bunch of new applications. So just talking a little bit about the smart home gateway devices, or smart gateway devices, is the complexities around that. Obviously, there's a whole bunch of wired interfaces, whether it's serial or industrial automation buses, whatever the case may be. And on the screen, I've just listed a few of the wireless type connectivity that you may get in a gateway, everything from Z-Wave, Zigbee, Bluetooth, all the way to LoRaWAN, and of course, cellular. And with cellular, we're talking about LPWAN on cellular, so NB-IoT, Cat-M1, and 4G, 5G, and in the future, 6G. So, it really complicates issues around managing those sorts of devices. So there's considerations around firmware over the air updates, not just for the embedded CPU and the gateway itself, but there may be additional modules on the gateway. So being able to do firmware over the air updates for those, pushing container applications or microservices into this gateway. Obviously managing all the various interfaces, and also then one of the most important portions of the solution is being able to orchestrate that data, being able to choose what sort of sensors, what sort of parameters you want to ingest, and the frequency or the sort of repetition and update rates of that sensor data, and with that data orchestration, obviously where that needs to be landed. So one of the considerations here is when looking at the sort of integration of all the devices in the field into this particular service that you're going to be offering, is looking at this cloud connector and taking a device management solution and integrating that into a cloud offering. So it could be a cloud offering such as Microsoft, Amazon, or Google. And in each of those cases, you may want to offer a solution on top of that, or you may have customers or an ecosystem of developers or system integrators that are capable of delivering and developing their own applications in those environments. So the cloud connectors generally allow for upstream, downstream communications and ingestion of that data. So it could be sort of Kafka cloud connectors or AMQPS, PubSub. So those are sort of the main ones used by the main cloud contenders. But it could be others such as RabbitMQ and MQTT and so forth. One of the other ways of ingesting data is using the RESTful API as well. That's also available, including the ability to do sort of a data subscription or subscription patterns on the API call, so that you get callbacks on data arriving from device into the management system, and that callback is data that you're subscribing to, and that gets automatically pushed into your web application. So there's a whole host of services and cloud applications available on each of these platforms, and they each work more or less in the same way, but there's a lot of nuances there. Okay, so that's sort of native cloud ingestion, pushing data into data lakes and sort of running analytics or reporting or any other custom enterprise applications you want to. The other way that we look at ingesting data is making use of the IoT cloud frameworks within the cloud provider. And for that, we support this sort of IoT bridge. An IoT bridge essentially provides for a seamless plug-and-play integration into that cloud environment. And within sort of Azure and Amazon and Google, they each have their own cloud IoT cloud services, and those IoT services go all the way from creating device twins or device shadows, or however that's represented in each of the clouds. But that device twin then propagates sort of dynamic templates into an IoT central dashboarding environment. So it's not only a dashboarding environment, but an environment where you're able to actually develop an application, be that the service provider providing an over-the-top revenue service, or be that, as I said, the ecosystem wanting to actually develop their own applications utilizing the carrier or the service provider's toolboxes. So yep, let's move on. So once you're ingesting that data and it is available in sort of the IoT framework, this is just some examples of the full plug-and-play integration from device management through the bridge into an IoT cloud. And these sort of dashboard applications represent some typical examples. This one here is a smart meter application. Looking at energy consumption and providing functions such as activating, deactivating the meters, or updating the firmware, or looking at energy consumption. Of course, additional reporting services could be provided, such as billing and other proactive services such as potentially heat mapping, and looking at the in a data lake environment, looking at this big data and what what you can actually do with that. So, and a good example there in the metering space is when you're heat mapping a whole bunch of smart meters in the field, you're able to determine particular patterns in particular areas. So these are all applications that can be developed in this cloud off the shelf. One of the applications, as I mentioned, we deliver is a smart home automation solution. It is available in this web application, and it is available on a smart home, a smartphone device. So that smart home automation application provides for the full ambit of carrier service to the consumer, and yeah, allowing for profile adjustment of in-home automation, you know, security, surveillance, video, you know, etc. Okay, so in looking at some of those complexities, we're just saying, you know, to be future ready, our Friendly One-IoT device management platform is a best of breed in this device management game. We provide a carrier grade service. We're utilizing some agile technology, and in particular the smart layer service, which allows for this multiple protocol support in protocol adapters, and allowing for sort of this API integration to the external world as well. We're supporting more protocols than anyone else. Our platform can be installed on cloud or on-prem, and that's pretty significant because we're completely cloud agnostic. We are not dependent on one specific cloud vendor, and so we're completely agnostic. However, as you see, we integrate into any of the clouds that are available today, and a big benefit is we do on-premise installations, and that's important in some cases, such as utilities wanting data sovereignty in a particular country or province or state of the country, having on-prem installation for those particular applications is very important as well. And providing a fully automated solution, so from the provisioning of the device to configuration, firmware updates, managing that device, the data orchestration, in the data orchestration, providing the connectors or the bridge interfaces into upstream cloud applications. Okay, thank you. And I think I have a few minutes for questions.
Yeah, no, thank you, Sean. Great way to kick off the session today and focus on one vendor's approach for IoT. Couple of questions that are coming into Q&A, and everyone please feel free, even after Sean's finished speaking, to add your questions in the Q&A. But one question here, are there limits to the scaling of the device management bridge to the cloud, such as within an Azure IoT environment?
Yeah, that's a good question. Thank you. So look, theoretically, there are limits, but it is unlimited in the sense of you can, if you provide the services in the cloud, you provide the scaling for that particular solution, it's essentially unlimited. So we have deployments in the region of 50 to 100 million, and we have a recent project where a customer wants to connect over 1 billion NB-IoT devices. So it's literally unlimited.
Okay. And one final quick question, if I may. Are the cloud IoT applications zero-code environments? And how much customization is possible?
Yeah, that's a good question as well. So from a zero-code point of view, the one slide I showed is both of these web applications here are zero-code. So it's essentially, you know, drag and drop widgets. So there is a lot of off-the-shelf capability with zero-code, but there is the ability to customize. So you're able to add in additional scripts. You could change widgets. You can add interrelationships between these applications. So the ability is there to develop the application to, you know, the next level, should I say.
No, I appreciate that. No, thank you so much. And great presentation, Sean. I'm sure we'll hear more from you later.